So this is the third video for week one. And in this video, we're going to talk about why add structure to an econometric model. What is that buying us that we can't get out of just a simple reduced form kind of OLS regression? So there are a few reasons that you might want to add structure to an econometric model. This list is not exhaustive, but it's meant to illustrate some of the kind of the top examples. And in your specific context, in your own research, you might have very different reasons for adding structure. But one of the big ones is to estimate some unobserved economic or behavioral parameters that just can't be estimated in a non-structural reduced form model. So something like marginal utility. When we get into talking about discrete choice later on in the semester, we're going to be using the random utility model, where ultimately we're going to be uncovering marginal utilities. This is something that we generally think utility can't be observed. So it's not something, utility just isn't even like a variable that could go into your OLS regression. So we're going to have to use these structural methods to uncover things like marginal utility. Marginal cost, that might be something that's actually observable, but in a lot of contexts, you're going to have data on firms, and you're going to want to kind of estimate some kind of the underlying technology parameters to construct marginal costs. That's going to be the kind of the best way to get at marginal cost in many settings, and that's going to require structural models. Things like risk preferences, discount rates, search costs, switching costs. You can imagine all of these things are important economic parameters, and you might have even run into some economic models where these are actual parameters in your model, but they don't always necessarily represent something that's observable or that's commonly observed that could go into to a more reduced form model. And so we've got to use some economic theory and some statistical assumptions to kind of build up the framework that we need to actually estimate these kind of unobserved but revealed through behavior parameters. Another great thing about structure is that it can help you conduct counterfactual simulations. You might want to ask, what would happen if the economic environment changed? There's some policy that you're thinking about analyzing, but it hasn't happened yet. How are you going to predict what's going to happen? Well, what you can do is estimate some of the underlying structural parameters of the agents that are involved in this policy. Once you've estimated all of those structural parameters, if you assume that they're not going to change as a result of the policy, people's preferences are their preferences, for example, then you can tweak the model and see what outcomes were before and then after that tweak and simulate those new counterfactual outcomes. And that's one of the things that you see done a lot in structural models, is that they're used to conduct these counterfactual simulations. Another thing that structure can do is to help you compare competing economic theories. So you might be wondering, you have some data on firms in some kind of an oligopoly setting, and you're trying to figure out, do firms set prices or quantities? How are they competing with one another? Well, in order to actually answer that question, you've got to set up a model that's accounting for whatever the implications of each one of these firm behaviors is. What would things look like if firms set prices? What would things look like if firms set quantities? And then estimate which of those models fits the data better. And to do that, you're going to need to work from an economic model and take that model really seriously. And that's what structural econometrics does. So that all sounds great. We should always add structure to our models, right? No. There are going to be a lot of contexts where structure can be really useful, but whether you want a structural model is going to depend on your research question, your data, your institutional details, everything. There are a lot of cases where you can do really great. And I mean, look at the literature. You can see there's tons of great papers written that don't mention structure or structural parameters at all. They're just using really kind of clever research designs to do reduced form work that's estimating really important and useful causal effects, even if those effects don't actually represent underlying structural parameters per se. And the reason for this is that there are actually some negatives of structural modeling. I built it up like it's a great thing so far, but there are some negatives. The first is that structural models require existing economic theory that's appropriate for your specific empirical context. And that might just not exist. It might be that you're in some kind of a very specialized context where where either the theory doesn't exist or getting an economic model that is actually kind of conforms to your setting is just intractable. There's just too much going on and it's intractable. So that can make it challenging to estimate a structural model. Structural models often require some additional assumptions, and sometimes many assumptions, and sometimes very strong assumptions by the researcher in order to align that economic theory with the data that you have available and some kind of a tractable estimation strategy. We're normally in a world where we don't have all the data that we wish we had. Sometimes we can overcome that challenge by making some extra assumptions. But to the extent that we're having to make those assumptions and then our results rely on those assumptions being correct. And if those assumptions are unrealistic or maybe even just questionable, then it's hard to interpret your results as being really credible. And people reading your work will question those results if your assumptions are also questionable. And then also it's just not always transparent to the readers, to the consumers of your research, whether those what those assumptions even are. They can kind of get baked into your model in a way that's not always clear to someone who hasn't thought as deeply about the model as you have. And so that's a downside. You want your research to be transparent and replicable, and to the extent that things can get kind of buried in unstated assumptions, that's not good. And then we can also talk kind of on the other side about what are the advantages of non-structural reduced form models. So, with a good research design, a good reduced form model is going to provide causal estimates. So you're going to get a direct estimate of how how a change in X causes a change in Y. There's usually less reliance on researcher assumptions here. You're usually going to be using just OLS. Everybody has a good understanding of how OLS works. And kind of what needs to be endogenous versus exogenous in OLS models for good internal validity is a little better understood. And so this is all going to lead to transparent assumptions, transparent estimation, and transparent results, which is just great for research broadly. Of course, without a good research design, the advantages of non-structural models are less clear. But with a good research design, non-structural models can be great if they answer your research question. So what I just said there makes it sound like maybe structural models just aren't credible. Is that right? Not always. Right? If you're having to make a lot of assumptions in the face of uncertainty about what the true situation and your true context is, then sure, that might be a bad trade-off. But that's not always the case. In fact, in some cases, adding structure to your econometrics might actually be the only way to credibly answer your research question. And examples of this is going to be where the question you're trying to answer is going to be some kind of a generalization to another setting. You only have data on one industry, but you want to generalize your results more broadly. Or you have data about things that have happened in the past, but you want to predict or have something to say about a policy change in the future. Some of these kind of out of sample counterfactuals. Something's going to happen in the future that just doesn't look like the data you have in the past. And so you're going to have to use structure to estimate what's going to happen in the future. Structure also adds some kind of a really nice way to make welfare calculations. And so to contrast that with reduced form, kind of reduced form treatment effects may not be applicable for out of sample extrapolation or for plugging into an economic model. In general, we probably think that structural parameters like marginal utility or risk preferences are going to be more likely to be invariant to whatever your setting is. Whereas kind of reduced form treatment effects, sometimes there can be so much baked in there that we might think that the policy itself is going to change in effect. And so it's going to be harder to interpret out of sample. And then similar for welfare calculations, it's going to be hard to think about how we might plug kind of reduced form parameters into welfare calculations in some case. And so a classic example, this comes from that Nouveau and Winston paper, a classic example is merger analysis, where we actually get credibility through structure. So let's talk about merger analysis. Suppose we want to predict the welfare effects of a horizontal merger. Let's think about start with the non-structural approach, then we'll talk about the structural approach. So the non-structural approach here would be to estimate the effect of similar mergers on prices. So look at some data on historic mergers that are similar to this one and look at have those mergers had on prices. Let's get a credible estimate of that. And then use that estimated price effect in a kind of back of the envelope welfare calculation where we can say something about, if this merger causes similar price effects, then this is how much consumer surplus is lost, how much deadweight loss there is, those kind of answer those kind of welfare questions. That's ultimately what we care about. Well, what are some potential problems with this approach? So first we have to think about what counts as a similar merger. We're going to use data on past mergers that are similar. What counts as similar? Do we want something in the same industry or a similar industry? Do we want to look at industries with similar concentrations? Products where demand elasticities are similar? Industries where cost structures are similar, right? There are so many different dimensions here on which to define similar that it's going to be hard to find, or just hard to even come up with what we mean by similar. And that just provides a lot of kind of researcher degrees of freedom, which sometimes are nice, but in this case it might not be, because what you think of as similar might not be what like readers and reviewers think of as being what they think should be similar. Then there's the question of, even if you can define what you mean by similar, are there a sufficient number of similar mergers? If you're talking about the two largest telecom firms merging with one another, that hasn't happened very often in the past. And so how are you going to find similar mergers for that? There's also the question of what's the control group then? Are you going to compare the results of a merger in this industry to the results without a merger in another industry? Are you just going to use an event study of these mergers? And then maybe even the biggest question here is, are these mergers even exogenous or quasi-exogenous? And if they're not, then we're estimating, once again, kind of interesting correlations, but not necessarily causal effects that we could even, might not even be the case if a similar merger happened in the same industry at a different point in time, for example. All right, but what can structure get us on this problem? Once again, we want to predict the welfare effects of a horizontal merger. Using structure, we can construct an economic model of demand, supply, and competition in this industry. We're going to kind of write down the model of what demand looks like, supply, competition. We're going to have some kind of an equilibrium concept of how this market clears. And that model, all those models are going to have structural parameters, consumer preferences, technology parameters for firms. We're going to determine what the nature of competition is, and we can estimate all of those structural parameters that are going to kind of describe the underlying economic setting of this industry. And then we can simulate what outcomes in this industry would be before the merger and then after the merger, using those structural parameters with our economic model. And that's going to include things like welfare. That'll just fall right out of our model. And we can do that under a range of assumptions. So maybe we want to assume two large firms merge. Now the industry is more concentrated. We can see what happens there. Okay, but maybe when two large firms merge, there's actually some cost reduction that comes from that. So we can also tweak not just the concentration of the industry, but some of those cost parameters, so that now this new larger firm is a little more efficient at production, and we can see what happens there. And so we can come up with a whole range of different assumptions and simulate what we think market outcomes will be under that range of assumptions. Of course, this comes with its own set of problems. How do you credibly estimate the structural parameters? A lot of times we think about finding instruments that we can use to identify every one of these parameters, but we don't always have a good set of instruments to identify every relevant parameter. So it's not that this comes without problems, it's just that it comes with a different set of problems. But if we can overcome this problem of credibly estimating structural parameters, then it sets up a really nice framework for credibly thinking about the effects of a horizontal merger. Obviously, both approaches have strengths and limitations. If you have tons of data available, then maybe the first non-structural approach is what you want to go with. But in a lot of cases, I think the structural approach here is going to be better. So that sets up another question here. Are structure and data complements or substitutes? It sounds like I just said if you have a lot of data, you can use reduced form methods. If you don't, you need to use structure. Is that true? No. Structure can still be useful even with lots of data. Both credible treatment effects and credible structural parameters can be useful. Data, having good data can actually improve your structural econometric model. Good identification can improve your structural econometric model, because when you have good data and good identification, kind of weakens any of the extra assumptions that you need in your structural model. Another way of saying this is that when you can rely on the data to do more of the work for you, then your assumptions are doing less heavy lifting. And that's true for both structural and non-structural approaches. So good data can be useful no matter which approach you're taking. But of course, when you have really good data, that might be a great setting to think about both combining both structural and non-structural approaches. So, it's becoming more common in papers to see maybe some non-structural, just kind of credible treatment effect methods used to get a credible estimate of kind of overall treatment effects, and then maybe a structural model used to dig a little deeper into some of the mechanisms and understanding why we're seeing those kind of overall treatment effects. So data is not necessarily a substitute for structure. And I would even say in some settings, non-structural models are not necessarily a substitute for structural models. They can complement one another really nicely. So the final video is going to be about how to actually construct a structural econometric model. So I'll stop here and we'll pick up with that in the final video.